This is a simple overview of the internal combustion engine, its components, and how it works. The cylinder is the main part of the engine. It contains the piston. Around the piston is a cylinder head, which contains the gases that will be combusted or ignited. The bore is the term used for the diameter of the cylinder. The piston has a ring around it to prevent gases from escaping. When the piston is pushed into the cylinder by the crankshaft, which is connected via the connecting rod, also known as the con rod, the piston compresses the gases within the cylinder, and the crown, or the top of the piston, becomes heated. The crankshaft moves the piston. It's the combination of a shaft, or rod, attached at right angles to the con rods, which are connected to the number of pistons the engine is designed to accommodate, and a crank, which is designed to transmit rotary motion, much like pushing a pedal on a bicycle or turning a door handle. A cam is an irregularly curved wheel and is mounted on a rotating shaft, or rod. Together, the shaft and cam, or cams, are known as the camshaft. That's part 1. This is connected to the crankshaft, part 2, indirectly by a belt or directly via a gear mechanism. Cams are curved in such a way that they control the position and speed on the crankshaft, and thus the piston movement within the cylinder, part 3. The movement created by these 3 interacting motions is known as timing. Timing is critical since there are 2 valves at the top of the cylinder that both need to be closed as the crankshaft pushes the pistons into the cylinder. Having no place to escape, the gases trapped within the cylinder are compressed, which ultimately heats the inward moving piston. At just the right moment, a spark ignites the compressed gases, causing explosion. So these are the parts, and next we're going to follow the 4 cycles as these parts work together. The suck process. The 2 valves at the top of the cylinder are moved by the camshaft. One is for intake, the other is for exhaust. When the intake valve opens, a mixture of fuel and air is drawn into the cylinder due to the suction created by the airtight piston leaving the cylinder. Same concept as a syringe drawing blood. Once the piston has reached its outermost limit within the cylinder, a spring, controlled by the shape of the cam, will cause the intake valve to close. Down suck. The up-squeeze process. When the piston is being pushed back into the cylinder and both valves are closed, the piston compresses the new fuel-air mixture within the cylinder. The friction, caused by the compression, is heating the top of the piston. Up-squeeze. The bang process. The spark plug fires, creating ignition of the fuel-air mixture now trapped within the cylinder. The explosion throws the piston back out of the cylinder with force. The movement of this process has created power, which can now be harnessed. Down bang. The blow process. The cam moves into position to open the exhaust valve to allow release of the now spent air-fuel mixture of gases. This time, though, as the piston begins to rise, the exhaust valve is open and there is no compression. The crankshaft will pull the piston to repeat the process. Down suck, up squeeze, down bang, up blow. And again, down suck, up squeeze, down bang, up blow. That is the basic idea of the internal combustion system. The number and arrangements of the cylinders can be varied. Each configuration has its advantages and disadvantages regarding smoothness, manufacturing cost, and shape characteristics that determine suitability for its application. Inline, flat, and V engines are popular options currently available today.